Okay, here's a roller coaster that we're going to be doing. Conservation of energy. First thing you need to do with all roller coaster questions is figure out the total amount of energy that the system has. So this is going to be a 300 kilogram roller coaster. At the top, the maximum amount of energy it's going to have is right here, where you're going to have your total energy is going to be your gravitational potential energy, which is going to be mass, gravity, height. So in this case, mass of 300, gravity is 10, height is 15. So your total energy for the entire system is going to be 45,000 joules. Okay, that is going to be the energy that you set against absolutely everything else. So let's do the first. Well, if we look at this question here, a thing that you could be asked is at what point is the roller coaster going to have the fastest velocity? So just by looking at this thing, I know that it's going to be at the bottom here. That's going to be the maximum velocity. So if I want to find my velocity here, that just tells me then that I'm going to have some kinetic energy. And my kinetic energy, since it's at ground level, 15 meters of stored energy is going to get converted into kinetic. So basically, I have a maximum value of energy for my kinetic, 45,000 joules. So my 45,000 is going to end up being equal to 1/2 mv squared. So 45,000 then is going to be 1/2 the mass of 300. Solve that thing out for velocity. So when everything is said and done here, 45,000 equals 150 v squared. V squared is 45,000. You see that? Divided by 150. So then my velocity is going to end up being 17.3 meters per second. Okay, nowhere else on this roller coaster will you get faster than 17.3 meters per second. Let's double check. Let's try right here. How fast are you going to be at point B? So we have a little bit of potential left, but most of it's been converted to kinetic. So let's see, I'll do it right here. So really what we're going to say then is our total energy, 45,000 joules, is going to be converted to kinetic energy, but it's got a little bit of gravitational potential left. So 45,000 is going to be equal to 1/2 mass of 300, and we want to know how fast it's going, plus my mass, gravity, height. So my, let's see here, I'm going to run out of space. My 300, 10, and I'm at 4 meters. So that is going to end up being 45,000 equals 150 v squared plus 30 times 10 times 40, that's 12,000 joules. So what I'm going to end up getting then is v squared equals 45,000 subtract 12,000 divided by 150. When all is said and done, my velocity there at point B is 14.5 meters per second. Okay? That makes total sense. If at the bottom I'm going 17, then just a little bit above the bottom I should be going less than 17. So I've just done 2. Let's figure out, this is an easy question here because I purposely put the same heights in. We could figure out how fast you're going up here. You would just go 45,000 and then set it against the kinetic energy and the gravitational here at 8 meters. And I'm not going to do it because it's the same question as this. If you want to do it, you can see if you get it right. If you find that your velocity is 11.8 meters per second. Okay, that tells you that you got the right answer. But here's what I want. I'm going to actually put, let's say I put a stopper here that is attached to a spring that's got a K value of 30,000 Newton meters. That means that when this thing finally comes to the bottom, it's going to have a velocity of this same value here. So it's going to be going 14.5 meters per second. And I want to know, when that hits this stopper, how much does a spring compress to stop that roller coaster? So let me see, I'm totally out of space on this page, so I'm going to go to a new page. So really, what I want to do then is I want to go, well, I know, and let me just redraw this here. Okay. I know that I'm coming in, here's my roller coaster, a couple wheels on it. I've got a velocity of 14.5 meters per second. It's moving this way, it's going to hit, it's going to compress. I want to know that compression until it stops, or until it gets to 0 meters per second. So I forget about my total energy from the previous part of the roller coaster question. I just say, look, my kinetic energy has to equal my elastic energy. Or you could go really long and go EKI plus EEI equals EK final plus EE final. I don't have any elastic because it's not compressed yet. And when I get to the end here, I have no kinetic, which is just what I said, EK equals EE. Okay. So 1/2, my mass is still 300, my velocity is 14.5 squared, and I want to know how far my 30,000 Newton meter spring compresses. Okay, so when I solve this thing all out, do the math to it, this half cancels that half, plug everything in, you should get a compression of 1.45 meters. That's how far the roller coaster has to have its stopper compressed to stop these people. So, there you go. We started off at the very beginning. Start off at the beginning, figured out our maximum energy, converted it to whatever amount of energy for any portion of the question. Then we did this last part right there. There you go. Conservation of energy roller coaster question.